Well, here we are, internet friends. We're going over the quest related to part 2 of properties of radicals. And let's take a gander at this, shall we? Simplify, combine like terms sort of thing. Let's rewrite this as 3 times the 4th root of 11 plus 9. Oh dear, is my pen acting up? Here we go. Plus 9, not 9, times the 4th root of 11. And because these have the same index and the same radicand, those are like terms, and I can just combine the 3 and the 9, just like I was combining like terms back in the day. So 12, 3 plus 9 is 12, by the way, times the 4th root of 11. There you go. There you go. Let's keep going. Let's keep going. Now, notice on this one, I remember what example 6 was. That was like the whole absval thing, where I've got to consider, are these variables positive or negative? And we don't actually ever fully know, and so we have to assume there's the possibility of them being negative, and we have to determine whether or not we need to have an absolute value. And that had everything to do with the index. But let's first break this up. Let's break it up. And so I'll have the 5th root of m to the 10th over the 5th root of n to the 5th. And so because the indices, the index, I like saying indices though, it sounds fun. Because these are odd, therefore no absval. Okay, and that's pretty much it. So the 5th root of m to the 10th is an m squared, and the 5th root of n to the 5th is an n. N. Bam. Boom. Good stuff. So make sure while you're doing these, go look up that little rule. That wouldn't be a bad idea. Write the expression in simplest form. And here they let us, from example 7 and 8, they let us just assume all variables are positive. And at this point, the version of the test that I'm going to give at the end of this unit, I'll just give you the ones where we assume they're all positive. Oh, this is sneaky. This is a cubed root, and this is a square root. So those are not like roots. I cannot multiply their insides. But let's see if I can simplify some stuff. So I'll have cubed rooted dub times the square root of, let's break this one up to a w to the 4th. And why am I choosing w to the 4th times a w to the 1st? Well, because 4 is the largest number that is divisible by the index, the invisible 2 that was there, right? The largest number that goes into 5, right, in terms of being able to add numbers. 4 plus 1 was 5. Square root of 25 is 5, and the square root of w to the 16th is w to the 8th. Let's keep going. What do I got? Oh, this can be simplified. Square root of w to the 4th is w squared times the cubed root of w times the square root of w all over 5w to the 8th. Now, what I can do, these, it feels like you want to combine them so bad, but they're different indices, so you can't, does not apply. There is something that I can simplify, which is this, and there's a bunch of different ways you can think about it. You could subtract the exponent, and then it'd be negative, so you'd move it back down. You'd have a w to the 6th in the denominator. You could subtract the little exponent from the larger one. 8 minus 2 is 6, and that gives you w to the 6th in the denominator. You also could imagine it as canceling out. I'm canceling out these 2 w's with 2 of those w's, leaving 6. Whole bunch of different ways you can think about that. But the end result is cube root of w, square root of w, over 5w to the 6th. Dub, represent. What a math. Here we go. Last question. Assume all variables are positive. That's nice. Thank you for letting me assume that. So let's see. 3 times the square root of x to the 7th is what this represents. Remember, the denominator of an exponent becomes the index of a radical. Whoa, almost messed that one up. And you can, we could have written it as the square root of x all to the 7th, but in this case, I believe it's more conducive to have the exponent on the inside, because then I'll be able to, like, that's the way we've been doing our reducing tricks. Tricksy tricks. And then this is a square root, and this is an x to the 7th. Let's see, now I could simplify both of these, or I could combine the entire things first and then simplify. Two different ways. But since they're the same right now, let's just do the 3 minus 5 is -2 square roots of x to the 7th. Not done yet, though. I can reduce this x to the 7th with that square root partially. And so what's the largest number that goes into 7 that's divisible by the invisible 2 of a square root? I believe that's 6. 6 is divisible by 2, and 6 plus 1 is 7, so this would be an x to the 1st. And so I'd have -2, the square root of x to the 6th becomes x cubed, in which I just divide 6 by 2, and multiply by the square root of x. All right, dunzo onezo. Wasn't that fun? You want me to say funzo, but I didn't. All right, have a great day, internet friends. Adios.